Okay, so we learned how to write linear equations if we are given a graph, if we are given a table, or if we are given a situation. Today, we're going to learn how to write linear equations if we're given a slope and any point on the line, not necessarily the y-intercept, but any other point. So we're going to learn how to write equations from a slope and a point. Now, let's review what we've already learned. To write an equation in slope-intercept form, we need two pieces of information. I want you to take a second. I want you to tell me what those two pieces of information are. So I hope you remembered that we need the slope and we need the y-intercept in order to write an equation in slope-intercept form. Now, let's say we know that a line goes through the point -6, 1 and has a slope of 1/3. Could we use that information and find the y-intercept? Well, let's look at the graph. -6, 1 is right here. And I know that the slope of this line is 1/3. So from here, I'm going to go up 1 and over 3. It has positive slope. And then I'm going to do it again. I'm going to go up 1 and over 3. And notice I hit the y-axis, right? So that would be the y-intercept of that line. Okay, so the y-intercept is the up 1, 2, 3. So the y-intercept is 3, right? So I now know that the slope is 1/3 and the y-intercept is positive 3. So the equation of this line would be y equals 1/3 x plus 3. Now that was not too hard, right? They gave us a graph. They gave us a point that was on the graph. It only took a couple of times of using the slope to hit the y-intercept. Not a big deal. But remember, graphing is not always that efficient. Now, let's say I have the point -6, -20, and it has a slope of 2. So think about where -6, -20 is, and using a slope of 2, how long might it take me to find the y-intercept? Well, our graphs that we use don't often go to -20, right? They're not that big. So graphing here would not be very efficient. But what do we need? We're given the slope. We've got to find b. So our whole goal today, what we're going to learn to do is we're going to learn to find b if b is not already given. Okay, so we know that slope-intercept form is y equals mx plus b, and we know that the slope of this line is y equals 2x plus b, right? They gave us a slope. We don't have the y-intercept. Well, how on earth are we going to find it? Well, we're going to find it from this point. This point is a point on this line, right? Every point on this line has to fall into this equation, has to satisfy this equation. Every point on the line has an x-coordinate and a y-coordinate. And the point they gave us has an x-coordinate of -6 and a y-coordinate of -20. So we're going to substitute that into the equation. So instead of y, we're going to write -20 equals 2 is the slope of the line. The x value they gave us is -6, so we're going to plug that in. And then we've got to solve for b. We're missing the y-intercept. Well, this is going to be a very simple equation to solve, right? So -20 equals 2 times -6 is -12 plus b. So I'm trying to isolate b, so I'm going to add 12 to both sides. I have run out of room, so I'm going to come over here. So b is -12 plus 12 goes away, and -20 plus 12 is -8. So I have m, that's 2. I have b, and so now I can say for this line, the equation is y equals 2x minus 8. Okay, so let's do it again. This time the line passes through the point 4, 6. It has a slope of 1/2, and we want the equation of the line in slope-intercept form. Well, they gave me m, right? So m is 1/2. So I know that if I use slope-intercept form, y has to equal 1/2 x, and then we have to find b. Okay, they also gave me a point. The x-coordinate of that point is 4, the y-coordinate is 6. So I'm going to say 6 equals 1/2, the x-coordinate is 4, plus b. Now I just solve. So 6 equals half of 4 is 2, plus b. I'm trying to isolate b, so I'm going to subtract 2 from both sides. And b is 4. Okay, so b is 4, m is 1/2. So the equation for any point on this line is y equals 1/2 x plus 4. And we're done. Okay, let's look at a couple of context situations, real world problems. So a taxi cab driver charges $2.40 per mile. We've talked about how there's a flat fee when you get into a taxi cab. Or no, I'm sorry, that's the rate of change, right? $2.40 per mile plus a one-time flat fee. When you get into a cab, you have to pay something before you start moving. So a 3-mile ride costs you $10.30. The first thing we have to do is find the flat fee. So remember, today we're given a point and we're given the slope. All right. So we see this $2.40 per mile. So M is $2.40, right? We don't need to use units, but we do need our decimal point. That's what that's called. And then they tell us that a 3-mile ride costs you $10.30. That's a point, right? That's a point. So the total cost, that's your dependent variable, that's going to be the $10.30. And 3 miles costs you $10.30. So here's our slope. Here's our point. The first thing it asks is to find the flat fee. Well, the flat fee, that's your initial value, right? We're trying to find b. So we're going to use y equals mx plus b. We're going to say y equals, I don't know if I've got enough room here, but y equals, my slope is 240 x, and I've got to solve for b. Okay, so here's my x value and here's my y value. So y is 1030 equals 240 times my x coordinate is 3, and I'm trying to solve for b. So we're going to use some calculators here. Calculator will probably be helpful since this is some decimal work. All right, so 1030 equals 240 times 3. I used my calculator, and that is 720 plus b. This is just a one-step equation. I'm going to subtract 720 from both sides. I'm going to go into this bottom part because it'll be all right. And I'm going to use my calculator, and 1030 minus 720 is 310, 3.10, and that is B. That's my flat fee. My flat fee is $3.10. That's how much it costs just to get in the taxi cab. Okay, so I know my rate of change, 240 per mile. I know how much it cost me just to get in. That's 310. That's M. That's B. Now I can write the equation to find my total cost, right? My total cost is going to be that $2.40 per mile, so 240x, plus the $3.10 that I had to pay just to get in the taxi. Okay, so you find B, you use what they give you to determine your point, and then you solve for B, write your equation. Okay, next problem. You're going to do a lot of this one on your own. I'll walk you through it. At the beginning of the school year, Ashley has money in an account from a summer job. She begins withdrawing $35 a week. That's important. She's withdrawing without depositing any more money into the account. After 5 weeks of withdrawing money, she has $514 left. Okay, so remember, we need a slope or a rate of change. We need a point. We need a point in the slope. So what is our rate of change? I'm going to give you a second. You figure out the rate of change. The rate of change, the slope, is negative 35. She's withdrawing. This account is going down, and she's withdrawing $35 per week. Okay, so there's the slope. Now we need a point. Look at the problem and figure out what the point of the line that we know is. Okay, so they told us that after 5 weeks, she has $514 left. So her balance depends on how many weeks it has been, right? So the balance is the dependent variable. That's why 514, and it has been 5 weeks. Okay, so we know M, we know the slope, we know the point. The question is, how much was in the account at the beginning of the school year? That's your initial value. That is B. So I want you to take a minute and I want you to use the process we've been doing. Tell me what B is. What's the initial value? Okay, so we took slope-intercept form. We plugged in the negative 35, that's our slope. We plugged in the point, 5 and 514. Basically, over 5 weeks, she has withdrawn $175. So if we add that to 514, she started with $689. That's how much money was in the account at the beginning of the year. Okay, now we have M, now we have B. You write the equation that finds the money in the account based on how many weeks it's been. And the equation is y equals negative 35x plus 689. She started with $689 in her account. She's withdrawing $35 a week. This is how we would find out what her total balance is right now. Okay, so here's one I want you to try mostly on your own. It says Joe has some money in his savings account and begins to add $400 a week from his paycheck. The account has $2,900 after 6 weeks. So I want you to write the equation, okay? So the first thing we need, remember, is we need the slope and we need a point. So find the slope and the point that we know. Okay, so the slope is 400. It's positive. He's adding $400 a week into his account. And be careful, these are written sort of backwards from the way we should write them, but it has $2,900 after 6 weeks. So the amount is in the account is the dependent variable. That's why that's after 6 weeks. So our point is 6,400. Okay, now I want you to solve for B. Find the initial value that was in the account. Okay, did you get B as 0? Joe was broke when he started, right? He didn't have any money in that account, and he got a job and started adding money to his account. Okay, now you have M, now you have B. Write the equation of the line. That's the easy part, right? Y equals 400x. We would not typically write that plus 0 out beside that. So since it is plus 0, that means the y-intercept is 0. That means this goes through the origin. What kind of relationship is this? This is a proportional relationship. When it's plus 0 out here, it's proportional. Okay? All right. Now, here's the next and the last thing we're going to add here. It says, how much money does Joe have in his account after 20 weeks? Okay. Weeks, as we see up here, that's our independent variable, right? The amount he has in his account depends on the number of weeks it is. So they gave us an X value here. They told us that X is 20. So all we're going to do is plug 20 into the equation. So 400 times 20, and we get 8,000. So after 20 weeks, Joe has $8,000. Okay, so now you know, given a point, a point and the slope, how to find B, how to write your equation, and how to use it to find more information.